Hi dear students, today we are going to discuss about the electromagnetic field in the unit name of Unit 4, time varying electric and magnetic fields. The name itself meaning is that, once again I repeat you, time varying electric and also a magnetic field, isn't it? So now we are going to discuss about electric field as well as the magnetic field in the conditions of time varying. Okay, so before that we are going to discuss about the objectives of Unit 4. What is your objectives of Unit 4? So, impart the basic knowledges on Maxwell's equations. So, why in the sense the Maxwell equations are very important in the electromagnetic field. Okay. So, next, what are the content are available in Unit 4? First topic, Faraday's law. Second topic, conduction and displacement current density. Third, Maxwell's equation in integral form and point form. Then finally, the third potential. Now we are going to discuss about our topic is Faraday's law. In before that, we are going to discuss about the introduction part. In case of static electromagnetic fields, the electric and magnetic fields are independent because of independent to each other. In general, the static electric fields are produced by the stationary electric charges, while the static magnetic fields are produced due to the motions of electric charges with uniform velocity or the magnetic charges. Thus, we can say that the source of an electrostatic field is an electric charges, while that of magnetostatic field is current through the filaments. Why in the sense? Because of now I have discussed about the electric as well as the magnetic field of time varying components. Okay, so now we are going to discuss about two new concepts will be introduced here in a time varying field of electric and magnetic field. The first one, the electric field produced by a changing magnetic field. Second one is the magnetic field produced by a changing electric field. Listen once again. The electric field produced by the changing of magnetic field. So second one, the magnetic field is produced by the changing of electric field, vice versa. So next, we are going to discuss about the Faraday's law statements or otherwise Faraday's law theories. The EMF introduced with the closed circuit proportional to the rate of change of the magnetic flux linkage and the direction of the current flow in the closed circuit. That means closed loop integral of the closed circuit is such that is opposite the charge of the sign changes of the flux. Once again, the EMF introduced in closed circuit, that means closed loop integral, that is proportional to the rate of change of the magnetic flux linkage and the direction. So, in this point, of the current flow in the closed circuit such that it is a opposite these changes of the flux. So, at the place we are going to put it as a -2 here. So, EMF, the electromagnetic field, that is equal to, or is electromagnetic force, that is equal to minus d pi divided by dt. So, in the unit of volt. So, that's why we are going to put it as V, where the negative sign indicates, already I told because the closed circuit such that it is opposite changes of the flux. So, flux is totally changed to the opposite because of positive is converted into negative sign. So, that's why here we are going to put it as negative sign d pi divided by dt into V. So, V for a voltage. The second one, if the closed path is taken by an n-turn filamentary conductor in the often sufficiently accurate to the conductor, consider the turns as a coincident and it because EMF that is equal to minus n. Why here it is used as a minus n in the sense already I told the circuit such a opposite changes. So that's why we are going to put as a minus n in the sense number of turns in a filamentary conductors. So d pi divided by d into V, where pi is the flux passing through any n conductor paths. EMF is measured in volt. We define as EMF that is equal to, already I told so the EMF indicated the closed circuit is proportional to. So that's why here it is used as a closed loop integral into E into dl. So the above equations is a voltage about the specific closed path. If any part of the path is changed, generally the EMF charges. So once again, so EMF that is equal to minus d pi divided by dt into volt. because of the unit is volt. Then why here it is put it as a negative charge in the sense because of the closed circuit such that opposite changes of the flux. So that's why here it put it as a minus symbol. Then the next step we are going to calculate n-turn filamentary conductor. If the closed path taken by a n-turn filamentary conductor, then only this equation will come. So EM of the above equation EMF that is equal to, so there is a same minus will come to here, n in the sense n-turn filamentary conductor. So n into T pi divided by dt into volt. Already the EMF is measured in volt. We defined as EMF as EMF that is equal to closed loop integral of E into dl. Thank you.